I'm Mark Cavanaugh for Cavi Coaches, and today I'm going to coach you up on using Newton's first law to solve problems. All right, so here we have a problem where a box is being pulled at an angle. So the first thing that we want to do is the first step is drawing our system schema. So we can see our system schema. We have the ramp, the earth, and the rope all interacting with the box, where the ramp has two interactions. So that interaction is not only the normal force, but also the friction force. So we can draw our free body diagram from that. We can see the four interactions. We end up with our four forces. We have a normal force, we have a tension force acting at an angle, and a downward force of gravity, and then friction opposes the direction that the object would move if it was moving or if it was not moving. So we have this force, this tension force that is acting up and to the right. So what we want to do is we want to break this down into pieces called components. So it has a component that points to the right and a component that points up. So what we do is we enclose a right triangle around the given angle, and we show that the up and right force has a part that points up and a part that points to the right. All right, so labeling these forces, we're going to use trigonometry. So we know that the hypotenuse times the sine of an angle is going to equal the opposite side, and the hypotenuse times cosine of the angle is going to give us the adjacent side. So the hypotenuse in this case is the tension force, so Ft sine theta and Ft cosine theta. So now we've drawn our free body diagram. So what we're going to do now is we're going to look at a problem. So we can see that we have a mass of 15 kilograms. The force of tension is 50 newtons at a 25-degree angle, and our first step is to find the normal force. So what we're going to do is we're going to write the equation that describes the forces in the y direction, because the normal force points vertically. So we start with our sum of forces in the y direction equals 0, or adding up all the forces in the y direction equals 0. I can see I have the normal force pointing up, I have the gravitational force pointing down, and I have this piece of the tension force pointing up, the Ft sine theta. So I'm going to add anything that points up, and I'm going to subtract anything that points downward. And because it's not accelerating vertically, those forces are all going to add up to 0, which is an application of Newton's first law. So we rearrange the equation to solve for the normal force, and we get the normal force is equal to mg minus Ft sine theta. Notice that we substituted mg in for Fg. That comes from the weight versus mass lab. We know that weight, gravity, the force of gravity, is equal to mass times g. So now we plug our numbers in. So I use 9.8 in this case. I let my students round to 10, as the AP exam does as well. And if you don't let your students round to 9.8, or your teacher doesn't let you, no big deal. I'm using 9.8 here. So we end up with solving for the normal force, 147 newtons minus 50 sine of 25, and we get the normal force is 125.87. So the last thing you want to do is just double check. Do the up forces equal the down forces? And in fact, in this case, they do. So now we're going to go ahead and find the frictional force. The frictional force is acting horizontally. So we're going to add up all the forces in the x direction, and we know applying Newton's first law, they equal 0. So applying Newton's first law, we just take the force that points to the right minus the force that points to the left. And to the right, I have Ft cosine theta, and to the left, I have the friction force. So Ft cosine theta minus the friction force equals 0. I can solve for friction to get Ft cosine theta equals the friction force, plugging 50 in for the tension force and 25 in for the angle. I type 50 cosine of theta, 50 cosine of 25. Make sure your calculators are in degree mode, otherwise you will not get the same answer. And you can see we have 45.32 newtons is the value of our frictional force. So this is how you use Newton's first law to solve problems. I hope you have a great day and an even better tomorrow. If you found this video helpful, don't forget to click the like button down below and subscribe to my channel, Cavi Coaches, and follow me on Instagram and Twitter at Cavi Coaches.